In this video, we will look at writing equations of lines, okay? So when we're looking at linear functions equations, we'll start with y equals mx plus b first, and then I'll show you some other forms that we use. The first question says, which is an equation of the line that passes through the points 3, 0 and 0, 2? So again, we need to be able to write it in this form. And to be able to write it in this form, we need to find what the slope is, okay? We need to find the slope, and then we also need to find the y-intercept. The easiest way to do it would be to graph in Desmos and then find these two information and plug it in, and that's what I'm going to do. All right, so what I'm going to do here is I will go ahead and put these 2 points in Desmos. Sorry. Okay, I'm going to put 3, 0, and then 0, 2. And there are my 2 points right there. So to find the slope, I'll just count. In the numerator, I have the change in y, which is -2. And then in the denominator, I have change in x, which is 1, 2, 3. -2 over 3. Okay, so that's my slope. That's it. I really wouldn't do it any other way than this for the SOL. So -2 over 3. And then the y-intercept is where it crosses the y-axis. So right here, I mean, that's 1 point, so it definitely touches it at 2. So I'll go ahead and grab that. Okay, so my equation is going to be -2 over 3 x plus 2. Okay, I can also go ahead and confirm this, putting it in Desmos by plugging the equation in. Y equals -2 over 3 x plus 2. Yep, see, that's the equation in line. It's going through these 2 points. All right, next one. It says the graph of the line is shown. If the line in the graph is shifted up 2 units, what is the equation? So if the line is just shifted up 2 units, that means that everything, all the points are basically shifted up 2, okay? What that means is the slope will be the same as this slope right here, which is -3 over 4. You can find 2 points. I mean, it's right here, but I can also show you on the line. It's -3, 1, 2, 3 over 4, 1, 2, 3, 4. Okay, and then the y-intercept of this line is shifted up 2, so the y-intercept would have to be right there at 3. So my equation will be y equals -3 over 4x plus 3. Okay, and that's about it. Which equation best describes the graph? So we just have a graph and we have this equation. You know, honestly, we can just plug it in Desmos, right? I graphed all the equations in Desmos, and then now I'm going to check which one matches the one I have here. Definitely not the green one, right? Because this line is going up. Looks like it's going through 2. So these 2 are going through 2, so I'll take off this one. So it's one of these. I would say it's the red one. That's the same graph. Even the slope matches up. So there you go. Y equals x plus 2. Right. Which graph best describes? So yeah, just same thing. You would graph it. I know it's going to be b, y equals -2, because it's crossing the y-axis at -2, and it's a horizontal line. Okay, but definitely just graph it in Desmos and just check. So y equals -2, and there you go. That's the line. All right, number 5, it says, what is the equation of a line that has the slope of 2 over 3 and passes through that point? So again, we need to find the two pieces of information, right? We need to know what the slope is, which it tells us, which is 2 over 3. And then we need to find the y-intercept. Well, we can try it in Desmos. It might get a little complicated, but I'll go ahead and try it, okay? I want the line to pass through 4 minus 1. So let me go ahead and put this point in here, 4 comma negative 1. So it has to pass through this point here, and it has to have a slope of 2 over 3. So I can go ahead and actually count. So it's up 2 over 3, up 2 over 3. As I'm counting, you notice I'm going to the right, but my y-intercept will have to be somewhere over here. So I need to count the same slope but going backwards. So that would make it down 2 and then to the left 3, okay? Which is the same as up 2 and to the right 3, okay? So same thing, it's just going backwards. So it's going to be down 2 and then over 1, 2, 3, okay? So here's my other point right here, which is at negative 2, negative 5, negative 2, comma, negative 5. So if I were to have a graph that's going through this, looks like my y-intercept will have to be here, which is at y equals negative 3. That's my guess. I'm not too sure. But I don't see that in my answer choice. No, it's not going to be that one. So let me try again. So, all right, I need another strategy. That didn't work because it looks like my y-intercept is something, it's like a decimal. So what I'm going to do at this point is I'll go ahead and start with y equals mx plus b. As always, this is always my starting point. And I'm going to plug in some information that I know. So for y, I'll plug in the y coordinate, which is at negative 1. For my slope, I'll plug in the slope that they gave me, which is 2 over 3. And for my x, I'll plug in my x coordinate, which is at 4, and then bring down the b. So now I can go ahead and solve this by just solving for b. So I'll go ahead and do 2 over 3 times 4. So 2 over 3 times 4. It's going to be a decimal, so I'll turn it back into a fraction, which is 8 over 3 plus b equals negative 1. And then to get b by itself, I'll go ahead and remove that. So I would subtract 8 over 3 on both sides. So subtract 8 over 3, subtract 8 over 3. Okay, what that does is it just cancels these two out, and then you have b equals negative 8 over 3 minus 1. Let me put that in decimals. Negative 8 over 3 minus 1. And looks like my y-intercept will be negative 11 over 3. Alright, so it's negative 11 over 3. So now I can go ahead and write my slope-intercept form. So y equals slope times your x plus my y-intercept. It's going to be d. The last thing I want to do is just go ahead and confirm it in Desmos. So I know that it has to go through this point. And let me just make sure this line goes through that point. So y equals 2 over 3x, that's the slope, minus 11 over 3. And there you go. That works. It's going through the point and it has the slope of 2 over 3. Okay, that's my answer. All right. What is the equation of the line that passes through the points negative 9, negative 6, and negative 4, negative 3? Okay. I will go ahead and put this in Desmos and then look at my answer choices. So I'm going to do negative 9 comma negative 6 over negative 4 comma negative 3 negative 4 comma negative 3. All right, I need a line that goes through those. So now just go ahead and put in my answer choice and see which one works. That is one way we can do it. But if you don't have multiple choices, how would you find the equation? And also notice that it is not written in y equals mx plus b because we have all these other numbers and parentheses. So this is actually written in point slope form. So the point slope form looks like this. It's going to be y minus the y coordinate of the point that you wanted to go through equals the slope times x minus the x coordinate that you wanted to go through. All right, let me see if I can figure this out using without using Desmos. So the y coordinate, you can pick this coordinate or this coordinate, it doesn't matter. Actually, I'll go ahead and pick this coordinate because I see the 4 and the 3 here. So the 3, so this is my x, this is my y, the point, y is at negative 3. So you have y minus negative 3 equals my slope. Now the slope, I can go ahead and figure that out using Desmos. So the slope looks like it's at 1, 2, 3, rise 3, and then the run is 1, 2, 3, 4, 5, 3 over 5. So the slope is at 3 over 5, and then x minus x1, and my x1 is negative 4. All right, so let me clean this up. So you have y plus 3 equals 3 over 5 x plus 4, because minus minus becomes a plus. And it looks like it is C. Let me confirm that using Desmos. So you have y plus 3 equals 3 over 5 times x plus 4. There you go. That works. It goes through the 2 points and it has the slope that I'm looking for. All right, number 7. What is the slope of a line with a slope of 2 over 3 and passes through the point? Okay, so I'll do it a little bit easier right here. We're just going to go ahead and plug this in Desmos. Here y equals negative 2 over 3, x plus 2 over 3. Well, first of all, it wants me to have a slope of 2 over 3. So I can go ahead and take out a and d because these both have the negative. So in Desmos, I'll take out the negative. And then I know that I want it to go through the point negative 2, negative 3. And so, well, it doesn't go through it. So it has to be answer choice C. Let me go ahead and do it in Desmos. So 2 over 3x minus 5 over 3. 2 over 3x minus 5 over 3. Yep, there it is. So it goes through that point and it has that slope. All right, a line with number 8, a line which is an undefined slope passes through the point negative 2, 5. What equation? What's the equation? All right, undefined slope. There's two types of lines that I have here. I have a vertical line. That doesn't look vertical. A vertical line and a horizontal line. Okay, the properties of these two lines is a vertical line has an undefined slope and its y equals. A vertical line has an undefined slope because it's going up and down, and then it's always going to be x equals. Okay, A horizontal line has a 0 slope and it's always going to be y equals. Since I'm looking for an undefined slope, it's going to have to be x equals, and it's actually going to be the x coordinate of my point, which is at -2. X equals -2. Okay, we can graph it and check, but it is that. All right, select the graph of the linear function. Select each equation, this is spelled wrong, equation that represents the function. So basically I'm looking for 3 functions that have this equation. I'll go ahead and pause the video if you guys want to go ahead and graph these and then find the graph. Let me go ahead and graph them as well. All right, so I graphed all the lines and I'm looking for 3 graphs that are the same. So let me go ahead and go through each one and then see which one is that graph. All right, the first one, no, because it's going through 4 and this one's nowhere near 4. And that one looks like it's the same one. It's 4 and then it has the same slope, so I'll keep that one. Nope. Yeah, it is that one right there. And then the other one, yep, that one. So these are my 3 lines that I will choose. This one, this one, and this one. Okay. All right, what is the slope of the line that is parallel? So again, when we have parallel lines and then we also have perpendicular lines, one thing you have to know is parallel lines have the same slope, okay, and then the perpendicular lines have the opposite reciprocal slope, okay, opposite reciprocal slope. So the first one, for the parallel lines at the same slope, and we can go ahead and graph this in decimals and find what the slope is. See how it's not written in slope-intercept form, so I can't just pick out the slope, right? All right, the slope is, that's a decimal, so I can't use that point, but I can go ahead and use this point right here, so that's down 1 over 2. So if it's the same slope, the slope is -1 over 2. I don't see it on here. Did I do the, hang on. Oh yeah, it's, I don't know what I'm talking about. Here, look, this is a decimal and then this is the decimal too, so I cannot use that point either. Start over. So I can go ahead and use this point, and then another one would be maybe down this one. So you'd have -1, 2, 3 over 1. Here, let me type it down. I like to always type it down. -3 over 1, 2, 3, 4, 5, 6, 7. All right, so it's A. Okay, so it's the same slope, so that's the slope. All right, write an equation of a line that passes through the point and is perpendicular to this. All right, so if it's perpendicular, it's going to have the opposite and reciprocal slope. So I can see, since it's written in y equals mx plus b, I can see that the slope here is 1 over 3. I can graph it in decimals, but it's just easier just to pick it out right here. So that's 1 over 3. For it to have the opposite reciprocal, you take the opposite sign. So if it's positive, the new slope would be negative. And reciprocal is you have to flip this. So that was going to be -3 over 1. So this is just end up being -3. Okay, so that's the slope. And then it has to pass through this point. So since I can see that they're all written in the point slope form, you remember when you have y minus y1 equals the slope times x minus x1. So y minus the y coordinate, which is 3, this is the y coordinate right there, y1, equals the slope, which I found to be negative 3, x minus x1, which is negative 5. So negative negative makes this a positive, and then you have negative 3 equals y minus 3. Looks like it's D. As always, we will go ahead and confirm this in Desmos. Okay, so I know I'm looking at this one, y minus 3 equals negative 3, and then x plus 5. Always just start with pressing the home button. Okay, so that's my answer. But again, what am I looking for? I'm looking for a line that's perpendicular to this other line that I have here, which is y equals 1 over 3 x plus 5. And they definitely are perpendicular. They look perpendicular, meaning it's crossing at exactly 90 degrees. And the last thing I want to make sure is that it's going through this point right here, the purple graph, my answer graph right there, which is negative 5 and then 3. Yep, it's perpendicular to this line and it's going through that point. Okay? All right, and then we have this word problem. It says, Aaron counted the number of cars in the parking lot during a school day. The graph shows the number of cars as function of the amount of time that has passed. All right, so let's complete the sentence. Complete this sentence to interpret what the zero of the function is. So when we're looking at the zero of the function, we're looking at the x-intercept, only the x-intercept. So the x-intercept is right here, and it looks like it's at 10, 0. What this means is, remember that the x is the amount of time passed. So at 10 hours, the y represents the number of cars left. It's 0 cars left. So after 10 hours, there are 0 cars left in the parking lot. Again, the key here is to know what the word 0 means, and then you go from there. All right. Thanks for watching.